Hello and welcome to Practical Programming. Today we're going to talk about logicals and using logic in Python. So last time we talked about variables and things that we can store as variables. We can do strings, we can do chars, we can do integers, doubles, or excuse me, not doubles. We found not doubles. We can do floats, which are double precision floats. And we can manipulate all this with math. Now, so I said in that episode that coding, writing code, is essentially two things. It's math and it's logic. You do math on things and then you do logical operations on that as well. So we're going to talk in this video about the logic. So how do I do logic on all this stuff? What does that even mean? Well, I might want to know if certain things are true and false together, right? So let's imagine that Let's construct a very simple example. Let's imagine that I have a store, and the store says you get a discount if you spend more than $25. Okay? So how would we do that? Well, we'd need a variable, so let me clear out what we had last time. So I would need a variable called amount spent. Okay? And so this variable represents the amount that the customer has spent. And let's say we set it to be $28. So now I want to know, should I apply the discount, right? So I would say if, and this is what's called an if statement, okay? An if statement is exactly what it sounds like. You're going to say, if something, do this. And then you can also add more to that. You can say, if not this, do this. Things like that. But I would say, if amount spent, and so that was, let me show you what I just did there. Notice I type MAO. This is why we're using this IDE, see, because it knows I have a variable called amount spent, and I probably want to type it. So I can just hit enter, and it will fill it for me. So if the amount spent is greater than 25, I'm going to put a colon here, and I hit enter, and see it tabs in, right? I said in the very first episode of this series, this is an indentation-based language. What that meant was the code that will get run depends on where it's indented. So if I have an if statement, for example, and let's just say I type print hello. If I just have an if statement, and let's say I do this, I make this 15, right? So this will not run. It expected an indented block. So let's finish this first. So I'll say this is 28. So if the amount spent is 25, I want my total cost to be 25, and let's say we give them a 10% discount. So we're subtracting 10% from the amount. And then if that's not the case, then they'll be charged the same amount. So that would be an else total cost equals amount spent. And then we're going to print total cost. Okay, so back to what I was saying about indentation. So the only part of this if statement that runs, or the part that's part of the if statement, is the indented component. So if I unindent this, it's no longer a part of it. It just runs no matter what. And in fact, if I put something here, right, notice this is kind of upset. This color is red here. It's not happy. That's because I've just broken this if and else statement. If and else statements have to go together, right? If you have an if and you want an else, it has to go with the if statement. You can't just have else, right? And first of all, it doesn't make sense to just have else anyways, but keep that in mind. In order to use an else statement, you have to use if first. So we're saying if the amount spent is greater than 25, do this. Otherwise, do this, right? And then we're going to print the total cost. So we can see they spent 28 and it was 25.2, right? So we subtracted 10%. Now, what if they spent 24? Let's see what happens there. So we change the amount spent to 24. Look at that. The amount spent was the total cost, right? So this is the basics of how this works. Now, there are many, many, many types of conditionals. So you can do less than. Double equals is equal to. The exclamation mark means it's not equal to. So if let's say I run this at 25, right? So the total cost will be 25. But if it's 24, the total cost will be 24 minus 10%. So anything that's not 25 goes through here. Anything that is 25 goes through here. Then there's and or. So that might be, for example, let's say if amounts, let's say there's another variable. Let's say you have to visit this store a certain number of times, right? So let's say that you have to spend greater than $25 and you have to visit the store more than 2 times, right? So let's say that that's the condition. So it's not just that you spent more than $25, but you also spent more than $25 and you've visited the store a lot, right? So we run that. And you can see here, well, our amount was not greater than 25, even though our time visited was greater than 2. So this part ran, not this part. If we raise this to 26, now we get the discount. Now we get the discount. You can also change this and say, or, right? Let's say we don't care whether you spent more than $25. Maybe if you only have visited more than, as long as you visited enough times, we're good. We're happy, right? So then we can say we've only spent $23, right? Which is not greater than 25, obviously, but the times visited is. So let's see what happens there. Look at that. We get the discount, right? So you have and, you have or. There's something called an XOR, which apparently is not implemented. There are ways of getting XOR, as I said in the very first series. Packages are really important in Python, and so for things like that, you need packages. But and or are the basics, and the last one is the not operator. But honestly, you can just use the exclamation mark or change your logic. I'm not a fan of the not operator. I've written lots of Python code, and I've personally never really used it. You can use not to invert variables. So like this does bear mentioning. So I don't like using these, but there's a variable type called a bool. It stands for Boolean. Boolean just means like true false, right? That's all we're talking about. So I could have my true false and set this equal to true. There you go. You have to capitalize the T. It's a built-in. But you see, PyCharm will color code this to tell me I've spelled this correctly. And if I do print not my true false, see here it flips it. So you can use the not statement to flip things. You can use not and. You can do not and. Not doesn't look right. This goes out here. So you put these in parentheses. You do not, and then this whole thing, right? So this is equivalent to not and. Then you have not or. Yeah, I've never really used this all that often, and this series is mostly about practical programming. So feel free to use the not operator, but I would say just make better logicals instead of not. And that's not to say you can't use not. Not has its place, but so, and then the last thing we need to talk about is if and else statements. So if else, not just if then else. So else, elif, and I put another. Spend more. Okay, so we can have an if, and then if that if statement, let's make this and, if that if statement is not true, we can check another statement before just saying, well, everything else do this, right? And in fact, you can do even more than that. You don't have to do just one. Caps lock. All right. So you can have as many elifs as you want. But basically it means check this one first. If it's not true, check this one next, then this one, and then this one. And then once one of these is true, it moves forward with the code, right? So if I run this, I get, let's see, I have 23. I've got an and statement. So it should run just else. But if I say 9, for example, Spend more, 9. And then I'm also printing this down here. Switch statements exist. There's something called a switch statement. I could cover that, but I've never really used them either. They're okay. Why not? I'll show you what a switch statement looks like. Oh, never mind. I just realized Python does not even have switch statements, which is good because I don't really like to use them. They exist in other things, but they're essentially equivalent to this, to be honest. They're just like a little different looking, but good. They're not in Python, and you don't need them. So that covers logicals, and you can use logicals in lots and lots of things. In the next video, we're going to talk about loops, and a loop is a way of running more than one piece of code over and over again, right? So loops are important because you need to know when to stop the loop. How do you stop going through code? Turns out you want to use a logical to do that. So, all right, well, I'll see you in the next one.